Hi guys, welcome back to another hopefully interesting video. I'm the CjFilter, smoking cigarettes and drinking beer, and yeah, talking about drinking beer. Cheers. Get this thing opened and cheers. So good, it's fucking hot here. And today I want to show you how to code a Lowpass filter in C++, and we will use VCV Rack as a platform. You can do the same in VST and whatever. And now I'm coding for a while, but coding filters is something like, oh yeah, this is really hard stuff, actually. And when you see the code like of filters, it's just weird math, whatever, mess. But then I saw a video by Jakub Ciopinski or something like this. Let me see. Yeah, Ciopinski, I think, Jakub. I hope I spelled your name kind of right. And Jakub is showing, actually check out his channel, his videos, this is awesome stuff. And he shows how to make a low-pass filter and other filters just with mixers and delays. Now, if you're not familiar to VCV Rack, you would say, okay, I maybe understand there's a mixer and cables, but where's the delay? The delay actually comes out of the kind of how VCV Rack is processing audio. So let me explain this just shortly. Check his video. So here you have an input.
We'll go down as we go.
Oh, he's talking. The master's talking. Here you have a mixer and input, and you use the output from the mixer as a second input, and this output is actually delayed by one sample. Now we have a sample rate, normally 44.1 kilohertz, so this is just a little delay. Later, when this output is processed, it comes back here. And this is actually how this filter works. And now you have 4 of these. That would mean 4-pole. This is called ladder filter, and it has a resonance that comes out of the last filter. So if you would have a 2-pole filter, it will come out of here, 3 here, 4 here. Actually, we will code exactly this. So our feedback always coming out of the last filter. And then you have one situation that leveling these two channels, so the original channel and the delayed channel, he's doing some math here with these modules. Actually, it's just meaning if this goes to 1 or 10 in this case, this goes to 0. And if this goes to 6, it goes to 4, so you will always have 10 in total, or in our code it will be 1 in total, okay? And the resonance that's coming out of this, the output of the last mixer, plus 1 sample delay because of this module, okay, has the same attenuator or the same amplification like this first channel, which is actually the cutoff, okay? So you have the cutoff, and this channel here will be the resonance, okay? Sounds easy, and it is. And so now let's try to code this stuff, okay? I need a bit of beer, just not a bit, just a sip. And when you're a professional coder and so leave the channel, just do something else. Yeah, this is for newbies, for people who are worse coders than I am maybe. And I'm actually not a good coder. So we start here with an empty VCV Rack module. How to get these knobs and inputs, just check out my last video. There I go over that. So I prepared an empty module that does nothing. And let's build this to make it, build it, and then run it. So this is our CjFilter. Oh, okay, it's bullshit what is written here. This is our CjFilter. I didn't, just some copy and paste, whatever. And we have two inputs, two outputs. We have a resonance knob, we have a cutoff, and we have a filter type switch. It's a knob, but it's a switch that goes from 0 to 3, actually from 0 to 3. So we have 4 different filters, and that's what we're going to code. Okay, so let's define some stuff here. We will need a cutoff. Actually, I'm coming from my favorite bar. So I had some beers. Cutoff is 1.f for float. Then we need resonance. Resonance is 0.f. We don't need this, but we will do it like this. Where's my ashtray? Okay, my ashtray is not gone away. So then we do an unsigned int. This is just defining variables. F type is 0, and we will make a pointer. Now, if you're not familiar with pointers, don't run away. It's just, a pointer is just an address in the memory, whatever. And we will need a pointer, which is written by this star thing times whatever thing. And they will be called channel. And actually we need 2 of those, so we make an array. Okay, now we have 2 pointers. Sounds good. Nothing is happening. And now, we'll save this. There should be no typo in, I hope. There is. Doesn't matter. Yeah, beer is my friend. Okay, and now we will do the next crazy thing. We will make a class. Oh my god, we make a class. Yeah, whatever. I'm not used to this too. So we make a new file and just save this as, now where we are, Rack, CjFilter, to this folder, and we will call this class CjFilter.h. Now this is a header file. It already exists. Crazy. I deleted it. Of course, I coded this once before. So now we have our class. No, we have our header file. Sorry, I need beer. And start with pragma once. That's just that this, wow. Yeah, this guy loves me once. That this file is just included one time. Now, there are 1,000 ways to make a class, and normally you make a header file and a C++ file, but I just go the lazy way and write class, and this is called CjFilter. Okay. Now, why do I do a class? That's just because I'm a lazy guy, and actually it would be easy when you code a filter and you do your next project and you need a filter, just include your class and use it. So that's my reason. I actually don't like this, but it makes sense. And as I said, if you are really like professional coder, just do something else. Just don't bother with me, with the old guy. So let's define some variables we will need. One is output. This is where we will replace our input with this, or we will replace whatever. We will assign our input to this. Okay. We will need a counter. Now I could do whatever. I just write that this way. Okay, color coding doesn't work good. Doesn't matter. And now what we have to do, we need our delays. Okay, so actually we should do something like a ring buffer. But what I'm gonna do is just kind of a fake ring buffer. It's just easier, and if it's not a real huge thing, it's an easy way to make a ring buffer. If you need a real huge ring buffer, don't do it this way because it will need a lot of memory. But this is just a small thing, and we will call this for our feedback, and then say 4. That's an array again. This is our 4 poles or 4 filters that we like cascaded, and let's give them like 16 values. Okay, it's not a lot. That's just a little thing, and we will need our outputs. So float filter output. I think that's okay. And this is an array again. Oh my god. 4. So you're getting things done, and I need beer. Now, I don't know if this is the right way to write a class, and I actually don't care. It's just, it has to work. CjFilter, and I think it's like this. Now we can define our variables, and this is output is just to make things nice, and our counter is a 0.f as well, and for int I is 0, I smaller 3, so 4 times I plus plus. Tick. And we will put another loop inside, so we got these 4 and 16 for int j smaller than 16, j plus plus, and now we will put here our feedback is 0.f. This is just to avoid noise or undefined behavior. So this is I and J, whatever J, I don't know. Okay. And we have this filter output, and we do the same here. Filter output I is 0.f. That's just to avoid undefined behavior, okay? Not a big thing. So now we have to make fancy stuff. Just I think this is CjFilter. I'm really not used to write classes, so this is just a destructor, and actually nothing happens. But yeah, I think this is how this can be written. I need a cigarette. Let's save this and let's build this. Oh, okay, close this, make, just to see if we have any typos in there or whatever. Looks good. Now we still have nothing, okay? And we have a class that's called CjFilter, like Jakob filter. And now we need a method or a function or whatever. In classes it's called method, to process our whatever we're doing, and we have to define this here. And we will use the pointer. You will see later why. So we will call this float. This our output is a float value. Pointer to filter. This is actually what we're going to do. And we need float input, float cutoff, and float resonance. Let's just cut this just a bit here. Just cut and res, and this actually should be enough. So this this pointer here, this method will actually output or return just a pointer. And the pointer means nothing fancy, it's just a address in the memory that we can access, okay? So, until now nothing happened. And now let's try to code something. So we will start with float times CjFilter do filter, and now let's just copy and paste this stuff in here. Yeah, this is how this stuff is done. This is not how I would like it, but yeah, beer. Now, first thing we do, we could do this actually here. Later in our code, but I will do this inside the class. Cut off, no, it's called cut, sorry. Times is cut. This is just making our knob acting more kind of logarithmic, so you have more way to go on the lower end. Yeah, whatever. Because our cutoff here is defined here, goes from 0 to 1. It's not actually completely 0 because it's too low to 1. So this is just to make things nice. And later we will need a feedback, but let's just do our filter. So we have 4 filters for int I is 0, I is smaller than 3, and I plus plus. So we will run this loop 4 times. And this will, we will do this actually always 4 times, even if you just are listening to one pole filter. We could run this 1 time, but I want the resonance, how I showed you, coming out of the 4th filter. It sounds actually better. I tried it before, of course. So let's write just the filter. And now we have output. This is just a temporary variable that we need. Is, no, that's bullshit. Output is input. So we just take this variable and assign it to output, okay? And then we will replace output by our code. Okay, is just output times cutoff. This is, let me see, this is what's happening here, okay? This is our input, now it's called output, and times the cutoff, that's actually here, okay? This is the cutoff knob. Check this video to understand. And we add here this feedback. Yeah, this is actually the output of this mixer, delayed by one sample. Actually, we still don't have a feedback, but we will create one. And this will be feedback, what we defined here, I. And now, yeah, which one? Actually, we have none, but we need our counter. So let's do some more code before. So after this loop, we will do this thing, counter plus plus. So we'll count +1. And here, if counter bigger or equal 8, I could say bigger 7, whatever, it's the same. We reset this, counter is 0. So our counter always goes from 0 to 7, okay? And now our counter goes from 0 to 7. I will write something in, this is our ring buffer. Actually, we will do counter plus 7. That's magic. That's our fake ring buffer. And in a second, you will understand why this is like this. We just have, this will be our feedback. And now we have two we need the amplification here. And this is all what's going on here. And this is actually times 1.f minus cut, and this should be like this. So that is calculated before. So when the cutoff is 1, this will be 0, and when the cutoff is 0.6, this will be 0.4. So this is just about the levels. And where's my cigarette? Okay. And now we define our feedback as feedback I counter is output. Now this won't work, yeah? But now we bring this to work, and this is our fake ring buffer. Just +8. So actually we are feeding this array 2 times, and this is kind of a ring buffer. So we don't, we could do other math, just changing this 7 to whatever, making math here. But if this is so small, I think this is completely okay. And now, filter out. This is, okay, it's actually called filter output. 5. Oh my God. I need more beer, I think, is actually our output as well. Output. And now something, I don't know if this is important, but I will do it like this. It's just, I don't know why. Let's do some more math here. Let's say this is input times 0.2. And then we are calculating between minus and plus 1 volts in VCV Rack. If you use this in a VST, just forget about this, or do some stuff here that you can define if it's VST or if it's VCV Rack, whatever. And here times 5. I don't know if this is necessary, but yeah. I think this 2 little multiplications won't eat up a lot of processing power. Just save this, get a beer. And now return what? Filter output. So and actually, this is the point why we are using a pointer. The pointer, use a pointer. A class in C++ can't, I don't say can't, but normally can't output more than one or return more than one thing. And as we are outputting a pointer, and the pointer is the pointer to this array, we can access all the members of this array later, yeah, from the outside of the class. So that's why we're using a pointer. I'm not a fan of this, but nobody is, I think. Everybody hates them. But they are actually useful. So what? Now we have a working class, like the working class people like to have the working class. And now let's do some coding. So we have here cutoff, resonance, f-type, and let's just get the variables just to make the code more readable, and at the same time cutoff and resonance we may add later, like modulation stuff like inputs, attenuators and stuff. So if you put this all in our call of the of our objects, it will just look weird. It's possible, but it looks weird. So okay, I say cutoff is inputs, just no inputs. What do I say? It's params. Params, and this guy is cutoff param get value. And now the same with the resonance is params resonance param, I think, yeah. Actually we have no resonance yet, but let's do this just now. And then f-type, I called this, I think. F-type is type param. Here it's written params type param, and actually saying get value. I hope I don't have a lot of typos in here. So now we have everything we need. And now let's go on with some beer. I need beer. This is so good. Now we have here our two channels, and these are pointers, okay? Just never forget about this. Channel. Actually, there's some stuff you could type like p channel, something like this. I don't know. Yeah, to never forget about that. This is a pointer, but I forgot about this, and so be it. Channel 0 is filter 0. Filter is our object. Oh, there is actually no object, so you should make one. Yeah, that's right. That's actually, yeah, we need an object. Okay, so it is CjFilter. This is our class name, and now we do make two objects that I call filter and object array. Okay. So the if you are completely new to coding in C++, um, if you make variables, it's float, you define them. It's float, cutoff, it's int type. It's actually the type of the variable, and the type of this variable is actually a class, so this variable will be a object. Yeah, something like this. It's always confusing. And our method is called doFilter. And now we need, let's see, input, cutoff, and resonance. So our input, yeah, I will do it like this. Input is actually something I don't like, inputs, but yeah. Input, get voltage, and then cutoff, resonance. So now this should actually work somehow. And copy and paste. It's just filter one and inputs. I always say that. Inputs plus one. So now actually everything should work somehow, except resonance. And now all we have to do is to output this stuff. And never forget about that this is a pointer. Yeah, I should have named this different, but yeah, it's actually too late. Outputs, tag, output, set voltage, and now we have to do crazy things. Now we have our pointer here, and we need to get the value of the, to get what is there at the address. And actually we have, this is our output. We have an array. So actually we have 4 different addresses, okay? Just saying, because we have a knob, there's a type param that is from 0 to 3, so 4 different values, saying which filter we want to have on the output. So, and this is like something like this. Oh, I'm bad. So pointer to channel. It looks scary. This is channel 0. And now plus F type. That's how we call this, right? F type. Where is it? F type. Yeah, it looks shit. But could work. Let's just copy this for our second channel. So it's output. Oh my god, I'm so late. And this is channel 1. Okay, now we coded a lot and didn't listen to anything. I think actually this could work. Yeah, I need a beer. And then we will just build this and listen to this, and then we will see. I hope you could follow me. I told you I'm back from my favorite bar. And was, oh. Okay, this is a lot of typo shit. So let's start at the start. Oh god. Okay. Struct CjFilter. How did I call this? Class CjFilter. Okay, give me a second. Okay, here we go. Of course, we have a class, we have a file, and it's late. And actually, we have to include this this header file, yeah, CjFilter. So include this. So let's see. Okay, this like this. We have to find the right path to include this. Let's see. Still. Okay, I was wrong. I saved this to the wrong place. And now let's save this. And now let's do make here. And now this should work. Output, vector, what? Okay, once again. Okay, let's see. We have some typos. This is just... Okay, that's bullshit here. That's when you're coding late. And outputs is some typo here, whatever. Okay. Outputs. Outpussy. Okay, let's just make... It's done, actually. Oh my god. So, let's run this. Make run. Okay, we have a filter. So, this is our input. And, okay, let me do something here. That's really important. Okay, we don't hear anything. This is because this guy is muted. And why don't we hear anything? Core audio. Oh yeah. Okay, here we go. We got our filter. I just have to go down here. See? Isn't this nice? And now, chuck, clack, clack, see? Okay, actually at 3, this goes somewhere down. So we still have some bullshit going on here, but it actually works. Okay? Nice. So let's see what we did wrong here. Yeah, of course. This is our do filter, and it should be smaller than 4. So actually this is working. I won't rebuild this just for that. And all we have to add is the resonance. This was actually fun. So, resonance. And now one thing. Let's go back here to this patch. And this is where the resonance happens. So it's meaning the output of the mixer is times -1, so it gets negative. If it's positive, it's just reverse, like in the polarity. That goes to the mixer with a certain value. This is our resonance knob, and is attenuated or amplified by the same value like the cutoff. Okay, actually not a big thing, not a big deal. So what we do here is plus feedback. Now this is, and we will use the last mixer, so it's 3. And now, ouch, counter. And I was playing around with this, and +6, yeah, does the job. Why do I do this this ring buffer thing? It's just because when you code this or check the files, when you're changing those values to 5, 3, whatever, you can do math here, you will get out really crazy results. So this is really something you can play with and experiment with, whatever. This has to be times resonance and times, I think, -1. No. This is, it's not just -1. -1 is this here. And then we have this cut-off thing. So it's times -1 point f. I think times cutoff. I think this should be the right thing. Let me just look at this. Yeah, I think so, because here this is going inverted, like to minus times -1. And here you have this, this is actually the cutoff here. So this should work. Let's just save this. No, no way. Because what we are doing now is wrong. Actually, this should be like this. If I is 0, this resonance thing should only happen on the first mixer. Now, how I told you, just you can experiment with this stuff, but just coding exactly this patch, else just copy and paste this in again. Oh my god, what I'm doing. Actually, I had not enough beer today, I think. That should be the reason. So let's get rid of this. And let's fix this, because it's not times, it's just plus. So we're adding the feedback. We are not multiplicating with the feedback. And now we should have some feedback. And believe me, this is not easy peasy. But yeah, make run. And now we got some feedback. Now this looks nice, but when I go higher, this thing will blow away. Like blow away, believe me. I just show you. See, it's gone. And this is something we have to fix, okay? Now, let's close this. Okay, just have some beer with me. We coded a ladder filter, a 4-pole ladder filter where we can switch the poles or the count of filters that are in line. And everything else is just some math you have to do just to fix the resonance, that it doesn't blow out. And there are several ways. Actually, I was talking with Jakub, and he said, put some clipper in this feedback here. And I tried this, and actually, it didn't sound good. So just give me a second, and I'll be back, and I'll show you what I did, because I've coded. Obviously, I coded this filter once, and now, yeah, I will show you how I fixed this and where I ended. Okay, give me a second. I will drink a beer. Just copy and paste some stuff, and then I will show you. Okay. Okay, here we go. Now I made a new variable. It's called damp. And first thing I do, if the cut is cut off, that goes from 0.1 to 1.0 is bigger than 0.5, I have a damp factor, and this is actually 1.f getting smaller if this cutoff goes over 0.5. And this is just 0.5. Now the cutoff is bigger than 0.5, so we have a negative value, and we add this to 1.f, and I multiplicate here our resonance loop or our resonance factor, or however you call it, with this damp factor. So this will just make the resonance smaller if the cutoff is bigger than 0.5. And actually this is very little math, yeah. And kind of same thing I do with the resonance. Just here, this is the same simple stuff, okay? So now let's build this, save this, and build this. Make, okay. Make run. And now our filter is at full resonance, you see. It's not blowing away. Now, of course, you could say, okay, but where we are, it's about a peak at 10 kilohertz, it's not 15, whatever. It's actually nice. And no, it's not self-oscillating and whatever, yeah. But we have a really nice little filter. And just to show you something, this is not an analog emulation. It's not, we are not emulating an analog filter. We just added filters and delays, yeah. And my point is, I need beer. My point is, often I just need a filter just to get rid of this high-end stuff. And this is actually doing the job, yeah. And now, Lateralos. I love this filter by Wood. Of course, everybody loves Wood filters. So let's give this filter the same input. And let's just go to this 4. For whatever thing, and let's just get here the output. No, like this. Okay, And now let's just see if we come somewhere close to this. Yeah. And you see? This is not bad. Now, the difference, of course, it looks really, really close. It may sound different, and I told you, this is not the same stuff. And look where our resonance is and where his resonance is, so he can make this filter cry, and there's much more stuff happening. But until there, actually we are not bad. And now, and this is something yeah, really, really crazy. We are here by 5.3% on my MacBook, and here it's 0.9. So this filter, it may be not the best sounding filter or low pass filter, but it's really lightweight. It actually consumes no CPU at all, not at all, but VCF. Let's just try out the regular VCF, which is, as we know since a few days, a super crazy thing. Just check out Jakub's last videos. It is, shall I say, annoying? It's 1.6, 1.7, 1.8, 1.9. So it's a double on CPU, mono, and this is stereo. Of course, this is high pass, low pass, and we have still a drive, and this tunes on volt per octave. This doesn't. So there are huge differences, but if you just need a low pass filter just to make not that crazy stuff, this thing is really nice. I love it. So whatever. Actually, I'm running out of beer at the moment. Yeah, this was my little low pass filter coding tutorial. Now with this code you can do really crazy stuff. I think we still have time. Sorry, let's change this to 5, and look what happened here as well. 5 or 7, whatever. Just now maybe this thing's gonna blow away. I don't know. Make run. It blew away, of course. So let's just wait until this is saved, and then we will restart it. Okay. You see, there's crazy stuff going on. See that? Okay, it's gone. It's up to you, okay? You can just play around with this, and if you get nice results or code anything with that, yeah, just leave me a comment. That's it for today. How to code a low pass filter without getting super crazy on math, and it's a few days later, and I had time on my favorite board to play around with this, and so now I made a final design and I added a few things. Now there's an input for resonance and an attenuator, same for cutoff. This is actually the same as before, and let's connect that. I added those LEDs that show when the parameter goes very low, very high. Yeah. So when you modulate this, you can see now you're full on. So you can just adjust this attenuator, and that's it. So yeah, I was playing around with the design, whatever. It's actually the same code, just with a few more things. And this is, yeah, how a plugin for VCV Rack can be made. Actually, I will link to the code and everything in the description below. And this Jacob's Ladder filter is available for free at cliffactory.com. So if you want to listen how it sounds, or if you want to use it, just get you the free edition or any of the other editions. There it is included as well. So that's it for this video. I will go for a lot of beers and cigarettes, and always the same. Cheers, salud, na zdrowie, skol, chin chin, whatever. See you next time. Ciao, ciao, bye bye.